So let's just do one more problem here. If f of x equals x to the fourth minus 3, let's find the inverse and do all those things. Oops, let me bring that thing up. There we go. So write y equals x to the fourth minus 3. We'll switch x and y. So x equals y to the fourth minus 3. We're going to solve for y, so we add 3 to both sides. X plus 3 equals y to the fourth. And I'll write like this. So what is going to undo this fourth power? Well, we're going to take the fourth root. So you can either write it like this, take the fourth root of both sides like that, or you can write it, if you like to use these, to the 1/4 power. The 1/4 power. Either way works. And what we see here is this is going to become y. And because this is an even root, right, you can see it here as well, the denominator is even, we're going to have plus or minus x plus 3 to the 1/4 power, or the fourth root of x plus 3. Okay, that is our inverse, so let's go and copy that over. We're going to get plus or minus the fourth root, or x plus 3, or x plus 3 to the 1/4. Okay, thinking about domain again. Domain, it looks like anything is going to be okay here. Positives, negatives, I'm not going to divide by 0. I'm not going to have a negative inside a square root. So my domain is all reals. My range, if I draw a quick sketch, again, x to the fourth is kind of similar to a parabola. It's just shifted down 3. So something like that. Oh, that's pretty ugly. But we know that y is going to be greater than or equal to -3. So we move this over here. Our range, x is greater than or equal to -3, which makes sense, right? Because that's going to make sure that this is going to be greater than or equal to 0. Exactly correct. And our domain, we copy this over, to our range, and we get all real numbers. Finally, to answer the question, is this a function? Again, one input goes to two outputs because of plus or minus, so no, this is not a function. And again, one final warning. Again, this guy also technically does not have an inverse unless we restrict the domain. That's because this initial function is not one-to-one, meaning it does not pass the horizontal line test. For one y, I have two x's, so unless I restrict it to, for example, this, I won't technically have an inverse.